Hey, this video is on lesson 69, which is the WhatPower function. This is an introduction to what we call logarithms. Now, a logarithm is a WhatPower function, and I'll explain what that means in a second. A logarithm is an alternative form of an exponential equation, and they're often used to solve exponential equations. Now, before I get going into what we're going to do, I want to just explain the concept of a WhatPower function. Okay, so they are WhatPower functions. For instance, if you see something that looks like this, log base 4 of 16, remember that log is a WhatPower. So what I'm really asking is, what power, or what exponent, of 4 is 16? So what power would I have to raise 4 to in order to make it 16? Well, 4 squared is equal to 16, so log base 4 of 16 is equal to 2. That's the idea of a logarithmic function. So if I was doing log base 2 of 8, you would say, what power of 2 is 8? And the answer is 3. And here's how you can check that. It's something that we call the swoop. I start at the base, which is the number down at the bottom. Remember, that's called the base. And I swoop through these. And the order in which I pass through them is the order in which I write them. So 2, 3, 8. So 2 to the third equals 8. Well, that makes sense. 2 times 2 times 2 is 8, so we're good. So we started off with a couple examples of that, just using the swoop. So these are all on the handout, which you can find on my website, mrjcostello.com. Go to Algebra 2 Files, and you can find the whole folder full of all these classwork files. Now, if we're going through these, log base 3 of 81 equals 4. I can change that into exponential form by using the swoop. 3, 4, 81. 3 to the 4th equals 81. You can check that in a calculator and make sure that it's true, and it is. Next, log base 5 of 125. Same swoop. 5, 3 equals 125. Yeah, 5 times 5 times 5 is 125. So we're good, that makes sense. Next, this one's weird. It's weird because if I try to do the swoop the same way, I get 12 to the 144th is equal to 2. Well, no way that 12 times itself 144 times is equal to 2. So the problem is that the log is not on the left now. So what I prefer to do is I say, all right, move the equals 2 over. We'll forget about them here on the left-hand side. And now I can do the swoop. Do the swoop, and you get 12, 2 equals 144. And 12 squared does equal 144. There's a couple more. I'll leave those, and I encourage you to try them yourself. So pause right now and try these 3. If you're still watching, I've assumed that you've unpaused and you already have the answers, in which case, here's how it goes. Equals 6, 2 to the 6th equals 64. Move over the equals 3. 4 to the 3rd equals 64. Move over the equals C. And B to the C equals A. Okay, now let's take it to the back. And resolve that. I want to start off with question 1. What we want to do is we want to evaluate each expression and verify it with an exponential statement. So we want to find out the answer, but we also want to convert it to an exponential form. So here's how we're going to do this. Log base 3 of 27. You can think of it as a WhatPower function again. WhatPower of 3 is 27. And the answer becomes very clearly 3. Well, how would I know that? Well, here's how I recommend setting these up if you didn't know how to start. What is this equal to? I don't know. So let's make that x. Now, I can use the swoop to convert this into the exponential form. That is that 3 to the x equals 27. And then it becomes obvious what we're looking for. Oh, what exponent would make this into 27? So it's not 3, it's not 3 squared. 3 squared is 9. I can check it in my calculator even. Check it out. I want to find out 27. So let's see. 3 to the second. Nope. 3 to the third. Yes, 3 to the third is 27. So I would just finalize this by saying x equals 3. We'll try number 2. Set it equal to x. Do the swoop. 3 to the x equals 243. And I'm probably going to want to guess and check this on my calculator. 3 to the what power equals 243. So let's see, is it 3 to the 4th? No. What about 3 to the 5th? Oh yeah, okay, cool. So 3 to the 5th is equal to 243. That means that x must equal 5. Now we'll do just one more, and that's question number 6 because it involves a fraction. Now here's what we know. I don't know what this is equal to yet, so I set it equal to x. I do the swoop. I get 3 to the x power equals 1 over 27. Side note over here, don't we know that 3 to the third equals 27? We found that in the previous question, in question number 1 on this page. Could that be helpful? Well, I want 1 over 27. So it's not going to be 3. X can't be 3. 3 to the third would be 27. So the problem is I have a 1 over it. What kind of exponent gives a 1 over something? A negative exponent does. So what I'm looking for is I'm looking for 3 to the negative third. That's equal to 1 over 27. So essentially x is equal to negative 3. If you have 1 over something, it means that you have a negative exponent. I can prove this to you, by the way. 3 to the negative third equals 1 over 27. I can prove that. The negative puts a 1 over it. So 3 to the negative third would become 1 over 3 to the third. And I know that 3 to the third is 27. I could also check this in the calculator. Three raised to the negative third power is some decimal. Hit math, enter, enter, and it tells me that it's equal to 1 over 27. So you have multiple options to check this. Your homework for tonight, I believe, is the rest of the back of the page, so complete that for the next time I see you. Good luck.